Cool. Welcome all to another LLM Instance Gateway meeting. Just a reminder, this is being recorded. We are uploading to YouTube, so act accordingly, and we are following the CNCF guidelines. So again, please be respectful to one another, and let's go ahead and get started. So as we can see here, we really have one main point. We'll have Song talk about the model server protocol. We hope to sketch out kind of want to discuss some of the metrics we want to get from the model servers and how. Hoping to get feedback there. I know we've reached out to VLLM specifically, and I think we have some momentum, but I will let Song speak to it more. Song, you have co-host, so I can go ahead and stop the share and hand it off to you if you'd like.
Thank you. Try to share the screen. All right. Can people see my screen now?
Yes. Yes.
Thanks for the confirmation. Hey, so yeah, today I'd like to talk about the model server protocol for the instance gateway. So as you know that as you know, the instance gateway is trying to make some intelligent load balancing decisions for model servers, and we do expect the model servers to act in a certain way. So so that means a lot of model servers already do what we can expect, and in the meanwhile, we also kind of ask for some information in the format of probability metrics or response headers we will get into that make the gateway work better for them. So that's the context. So I guess without further ado, let's dive into the details. Yeah, the first thing is about the API protocol that the model server talks. So we currently support the OpenAI's API protocol. So specifically, the instance gateway currently inspects the body of the inference requests and get the model and prompt and maybe some other parameters based on the OpenAI protocol. That said, we're open to support more, in the future, if there's more popular protocols, whatever. But that's the current expectation. And sorry, I'm presenting the screen, so I cannot see questions. Please, let me know, Kellen, if there are any questions or.
Yeah, I gotcha.
Thanks. So any question on this? I'll pause for maybe 10 seconds and see. Do people know if there are, some popular protocols out there that we should consider at this point? Okay, I guess I'll move on. Yeah, the next part is about the model management and also specifically LoRa adapter management, because currently the instance gateway does have very deep optimization for LoRa serving, specifically dynamic LoRa serving. So it's worth noting that this is not a kind of hard requirement for the gateway to work, but having these properties in the model server basically benefits most from the gateway. So the first thing about dynamic LoRa serving, so the gateway, I guess, works best for a model server that support dynamic loading and serving LoRa adapters on the fly. And that means we do expect the model server to be able to serve multiple LoRa adapters in parallel in the same decode batch, as long as the capacity KV cache or whatever allows. And we also do expect a model server to support dynamic load or unload adapters in the GPU memory. And it sounds like most of the model servers today that supports LoRa serving have this concept kind of layered caching. They can cache the adapters maybe in the host memory or on a disk or from some remote storage. And upon request, they can dynamically load this to the GPU memory. And also we do expect or would like to work with model servers to support register and unregister LoRa adapters dynamically without restarting the model servers. Again, this is not a requirement for the gateway itself, but this generally makes the tooling around this, like for CI/CD, much easier for example, the platform teams to manage the lifecycle and roll out a new versions of LoRa adapter without restarting, your pool of model servers. So we do not want to dictate how this should work. Maybe a reference API can look like this. So you, for example, to register a new adapter, you could have a post HTTP request with the ID of the adapter and perhaps with some metadata, for example, the path to where to load this adapter from. And similarly, you can delete or unregister this adapter. For example, you roll out a new version of adapter and the old version you want to kind of unload it. We know that Jashin, had a proposal and implement some of the effort in LLM to support this feature. I'll pause for maybe half a minute and see any questions on this.
Do we, we're not specing here that the model server, for example, should or should not load it from cold storage or send it to, if it has like multi-layer caching, to a specific caching layer, right? We're just basically saying that this API is supposed to indicate to the model server that this is a new adapter that it should consider, or at least like we expect that it would respond to requests, sent to it for this new adapter. But it doesn't say anything about expected performance, for example, when we do it.
Yeah, that's right. I mean, when we get to the metrics, I guess this is a good discussion point.
I think because we're trying to create a spec here, like we probably want to call this out, that the expectation here is once a registered adapter means that the model server is expected to respond to requests for this adapter, but it doesn't indicate anything about how it should be loaded, right?
Right. Yeah, that's a good point.
Or when.
Yeah.
This is the protocol just simply saying that this API surface should exist. Is that right?
Yeah, that's right. So again, this is not, what, our gateway really requires. It's mostly for the tooling around this to manage the life cycle of adapters.
It's unfortunate Jiaxin's not able to be here today. I bet we can follow up on this specific portion next week once Jiaxin has shared their LoRa doc in this. I think merging those two would be really, really good. I think we could get some good community alignment there.
Yeah, agree. Okay, so I'll move on to the next part. That's, I guess, the bulk of this doc, and we'll probably have a lot of interesting discussion there. So For the gateway to make good decisions, we do need to understand the kind of current the state of the model servers in terms of the load, and also Abdullah touched a little bit on the kind of cost of doing things. And by getting those insights, our gateway can make much better decisions. So, and let's dive into what kind of information we expect from model servers. So I guess I'll directly go. So I'll just show you. There's a list of things that I put here, and we can go through them one by one. But before I go through, and a lot of them are already very familiar terms to most of the folks here, I believe. For example, how many requests in the queue? What is the queue cache utilization? Things like this. And there's also a few new things. But before I go to them one by one, so I'd like to present the kind of protocol or the format we're proposing here to report these metrics or load and in terms of load and cost. So many model servers today already have their own kind of metrics reporting usually in Prometheus. And here we are proposing the model servers should also integrate with this Orca protocol, which is an open protocol for reporting load. And what's nice about Orca is that it's very lightweight. It supports both inbound and outbound reporting. In the inbound reporting case, the caller or the load balancer can just get the load or cost metrics from the response of a request and in the format of response headers. So this is already supporting Envoy and gRPC. I think Andres is on the call. Maybe Andres can give us a an overview of Orca. Andres, are you on the call?
Yeah, I'm here. Hello everyone. So Orca is it's an open standard for reporting either cost or utilization metrics from backends to some sort of data plane load balancer. So we use the terminology because we want to include both gRPC, right, proxyless type clients, and also proxies such as Envoy and others like Nginx, etc. And really what we've specified is a proto, right? A protocol buffer, or it can also be reported as just as an HTTP header field, right? So we also support non-proto encodings. But fundamentally, we are specifying a set of metrics that we consider common enough to be formalized, such as CPU utilization, memory utilization, etc. And then we also support just opaque metrics from the backends, and that could be whatever cost or utilization metric is most relevant for the use case. So it could be things like KV cache utilization in the case of an inference workload. It could be token computation latencies, etc. And although histograms do present some challenges, so that's something that's currently being worked out. And yeah, I mean the way that these reports are actually provided to the data plane load balancers is via a couple different mechanisms. We support inline reporting with the in the response header. So there's a well-defined header endpoint load metrics where we specify a couple different formats on how the report can be specified. And these response headers are then parsed by the data plane load balancer as needed. There's also the possibility of reporting out of band, so exposing an endpoint in the backend that can be queried, and that can be done at whatever interval is deemed appropriate by the data plane load balancer, by the client. And yeah, I mean that's the high level overview. It's not overly complex, right? This is a fairly straightforward protocol. Any any questions here?
I'm presenting the Orca doc if you guys can see it with some examples. It's pretty straightforward, like Andrew said.
Yeah, we're looking to publish this in the CNCF XDS repo within the next couple of days, just to make it more easily discoverable.
All right, don't see questions there. So I guess I'll move on to. So going back to our proposal, so we proposed a North Star that, for in-model servers should natively integrate with the Orca, load and utilization reporting, and just make it easier for any data plane load balancer like Envoy or maybe others who support Orca to make, better load balancing decisions. It's good to have, some open standard, and since Orca is already adopted by Envoy and others, so we think it's a good format to pick. So, but that's kind of the North Star that we're thinking, and I think Google here will probably fund some of the initial effort to kick this off, and then and engage with the communities of model servers. I know there's already discussions with LLM and Triton, so yeah. So I guess there's so sorry, this format thing. Let me make this. So but before we get there, to the North Star, and everything have Orca and everything have a standard, what do we do now? So as I said, so a lot of the information we need today already exists in some form of Prometheus metrics or some form of via some API or whatever in the model servers today. And there is also ongoing effort on standardizing and even unifying the metrics across model servers. So we would like to leverage those as much as possible. So for the short term, what we're proposing is, if the information already exists there, so let's just use it. Maybe there are a couple more things, for example, like some LoRa metrics. So we can just add to the existing metrics. It's pretty straightforward, and it's generally useful for the model server. So, and then we will have the instance gateway to integrate with the existing metrics, so and to get us unblocked. So really, it's it's just adding a few more things there, if not there, and that generally useful. And by doing in the meanwhile, we're just making sure we are aligned with the existing standardization effort, making sure for example that the metrics names are kind of consistent there. And we already started adding some neural metrics to VLM, and we already had a PR. So Quinjin here had a PR to add some LoRa stuff in VLM metrics. It's already merged in the upstream, so we'll switch to the upstream VLM. When we started, we have a fork of VLM for those metrics. We should be ready to switch to the upstream one. So the next feature we're proposing is the Orca response header or the in-band reporting, and this in-band reporting is already supported by Envoy. And what this does is we'll work with the model server communities to inject the kind of the metrics into the response of each inference request, and the gateway will get visibility into that directly from the response headers. This works well in if you have sort of like a consistent load, and it may not work well for like a sparse traffic or like a streaming use cases. So that's something that in the next phase or in the North Star we can get to. But for this phase, for kind of use cases that works well with the in-band reporting, having the model server integrated with that, significantly reduces the overhead of our gateway has to kind of have adapter code for each and every different model servers and delegate the responsibility to the load balancers. So the approach that we are leaning towards right now is to have the model server just just link a library, and then because the Orca protocol is really very straightforward, and the library should be very lightweight, so we can just get that native integrated. An alternative is we could have a sidecar that kind of intercepts the responses and inject those information, maybe by querying existing promises metrics or something. But that can come with the cost of some more hops that we add in the data paths, and also maintenance and overhead of keeping the version compatibility, upgrades, and stuff. Would like to hear any feedback on this, or anyone has done similar kind of investigations with directly library integration approach versus sidecar.
I think we should bring this topic to the larger meeting probably next time as well, just to open up the discussion with a larger group of people, because it's related to the model server in general. Like it's used by the inference gateway, but it would benefit from presenting this in front of larger community, working group serving community.
Sounds good. Yeah, then the final phase is really about also supporting the out-of-band reporting that I just mentioned. Having the model server has a some endpoints, for out-of-band reporting. Yeah, I didn't add too much details here yet. This is a probably a little bit far away. So if people are interested, we can dive deeper into this. Yeah, maybe now let's move on to the kind of the actual metrics that we are thinking. And this is, I guess this will evolve as we understand. So most of the metrics are derived from the algorithm. So if Abdullah, shared the algorithm, I think it should be in the meeting notes for the incident gateway. So the algorithm proposes, the routing algorithm there, needs some information from the model server. So I'll start with them. So the first one is the prefill and decode latency per token. Some of the model server already have it. For example, in LLM, this is a histogram metric. Sorry, let me make this a little wider. Yeah. Okay. And this does pose a little bit of challenges with reporting in Orca. So Orca currently does not define very complex time series like histogram. So that's something we can open as an open discussion. Andres has some inputs on this.
Yeah, we'll work through how to best represent this in the load report.
Yeah, I guess as today in Orca, we could either have the load balancer kind of get the latencies per request, and having insights into the tokens of the input and output, and can aggregate that way, or have the model server calculate a percentiles. But that we do need to define the time window, so that's less flexible. And the next set of metrics are about the queues. So basically, we are interested in the number of requests in the queue and the number of tokens in the queue. And this is, I guess pretty straightforward. Should be. We do know that in LLM that LLM is the first model server we are integrating with in the Git instance gateway. We have the request. We do not have the tokens yet, but this, also generally useful. So we'll basically working with the standardization effort and just try to get this in as well. So the other part is about the cache. So in here, we would like two metrics. One is about the utilization in terms of percentage. And the other one is the total size of the KV cache. So again, in LLM, we actually have both, but the max token capacity is exposed in indirectly in a metric, but it's available. The standardization effort also proposes adding this directly to LLM. So and to TGI and to Titan as well. So I think the last part is probably the interesting one is about LoRa's. I guess I have to admit that LoRa is kind of a new thing. I don't think there is a standard way of doing LoRa's. So we are proposing this based on our case studies of looking at a couple model servers who handles dynamic LoRa loading, and these kind of three metrics seems to make sense. But this is a new field; it may evolve. So we may update this as we go. So what we want to have today, right now, by looking at model servers, first we want to understand the maximum of active models a model server can serve. This generally means how many adapters you can load into the GPU memory. Because if you already filled the max active LoRa mod, active LoRa adapters, you cannot. So a new request with a new LoRa adapter basically have to be queued. We also would like to see the current active models that's being served in the batch. The reason being that if we send a new request with the same adapter that's already being active, and suppose you have enough KV cache and and enough capacity, and model server generally can take this immediately without further queuing this new request. So this having this information, significantly impacts the latency of a request. So that's why we are so interested in this. And the last one is available models. So this is basically for the gateway to be more, resilient. We can actually check what models are available. So we do not send a request to a model server if a model is not available for whatever reason. This is kind of like a health check, but like on a per model basis. Okay, so I guess we're at time. Any questions here? And feel free to comment on the doc.
So as a next step, I think, I'm not sure if you shared this with the work group serving Google group. Or was this, I'm assuming this is the first time we're presenting this, right?
Yeah, right. And yeah, I guess we'll try to find a list of the metrics and the definitions with all the details of type or whatever, and then we start into engaging with the model server communities.
Okay. Another thing we should consider moving forward is we want to find if the VLLM community have a recurring meeting. We can probably join that and present it to them.
Yeah, sounds good.
Awesome. Thank you so much, Song. I think we are a little over time, but yeah, this was great. Thanks all for coming, and we'll see you next week.